Assalamualaikum warahmatullahi wabarakatuh. In the last video, I already explained about the steps in gravity analysis. So please remember they have 6 steps. The first one is preliminary treatment, and then second step which is precipitation, which is I will explain in this video, and the third step is digestions, and then filtering and washing, and the fifth step which is drying ignition, and the last one is calculations. So in the last video I already explained about preliminary treatment, and then some of digestions part, peptidization parts in step 3, step 4 filtrations and washing, and then step 5 which is drying and ignition. So this video I'm focused on part 2, step 2, which is precipitation. Okay, first, what is precipitation? Okay, precipitation is the process which occurs when a portion of dissolved chemicals leave the solutions to form a solid. Which means that if you have a liquid sample and then you analyze in dissolved form, so you need to convert this chemical, this analytes into the form of solid by precipitation process. Okay, so we have several types of precipitate. Okay, first is granular precipitate, which is very desirable in gravity analysis. So our focus to make our precipitate to become granular precipitates, because it presents a relatively small surface area and less liable to contamination. So if you have small surface area, so the contaminations occur around the surface area will be less, and it also is easier to be filtered from gelatinous precipitate. So what is the granular precipitate? What is the good precipitates? Which is precipitate that made up of a large particles, or we call as crystals. It is very desirable in gravimetric work because they have large particles are very easily to be filtered, and we can also minimize the contamination from the impurities. Why? Because large particles contain relatively small surface area. So the precipitate also should have low solubility in the solution. Means low solubility means they are good insoluble in your solution. Okay, so we have two types of precipitates that we will discuss in this chapter. The first one is crystalline, which is have large size, and it will settle spontaneously and easily be filtered and purified. And we have low RSS, which is I will explain in the next slide. And then the second types of precipitate, which is colloidal suspension, which have tiny diameter around this size. Okay, so it will not settle down and not easy to be filtered, and they have high RSS. So what is meaning by RSS? RSS is the relative supersaturation. RS is equal to Q minus S over S, which is Q is the concentration of the solute, and S is solubility of precipitate at equilibrium. So you need to remember this equation, but you don't need to do a calculation based on this formula. You just need to remember this formula, and of course these 2 points. Very important. So this is the relationship between RS, relative supersaturation, with your precipitate. Okay, when you have a large RS value, means that precipitate is colloid, which is not good, because during RS large, so precipitate is colloid, means that nucleations is dominant, small particles of precipitate produced. Okay, so when RS is small, the precipitate is crystalline. This is our main focus. Okay, we need to produce a crystalline precipitate, which means that they have particle growth more dominance compared to nucleations, and will produce a large particles of precipitations. So this is the relationship between relative supersaturations, mechanical involved, and size particle produced. Okay, what is the properties of good precipitate? What is good precipitate? How we need to be able to detect, okay, this is a good precipitate. So first, it must consist of large crystal. so they can easily be filtered and free from contaminations. The second one is sufficiently insoluble to the amount of analyte lost during filtrations and washing will be really low. So it must be sufficiently insoluble. So we can avoid any loss of our analyte during filtration and washing. And then must be stable. Okay, should be unreactive with constituents atmosphere. And the last one must be of non-composition after it tried or ignited if necessary. So the last compound yang you get, you must know the composition of the compound. So how to get the property of precipitates? Okay, so the ideal precipitating agent or precipitant should react with the analyte to give these 4 types of precipitates. So how to form the large precipitate or precipitate. So this is your ideal good precipitate. So how to get this kind of precipitate? So you must do something lah. Okay. So the large particle in granular form can be achieved by, so to get this, so you should do a precipitate from dilute solution. Okay, and then next you need to add precipitating reagent slowly and stir effectively. And then you need to precipitate in from hot solution and at low pH. And you might need sometimes lowering the temperature slowly, or lastly adding organic solvent that can mix with water. So usually you need to remember at least 4 of these steps how to form the large particle of precipitate. Okay, this is another one, same as this part, so you can read by yourself. And then, so how precipitate form? So you know what is the good precipitates. So how to get the good precipitate, but what is actually precipitates? How it forms? So usually precipitation process occur when your analyte plus the precipitants or precipitating reagents, we go to supersaturations, and last one is going to form precipitations. So what is precipitating reagent or precipitant? It must be chosen for the ability to be selective and to form highly insoluble precipitates. Okay, and of reproducible stoichiometry. So they must have stoichiometry. If you don't have stoichiometry, so no reaction, no process occur. And as I can share here, we have 2 types of precipitant, which is organic and inorganic. Okay, usually what you have learned, what have been asked in the question usually is inorganic precipitants. So what is the difference between inorganic and organic? So for inorganic precipitants, usually they form slightly soluble salts or hydrates oxide with the analyte, while for organic precipitant, usually you use full precipitates, metals. Okay, and inorganic precipitant, most of these precipitants are not selective. Means that one precipitants may be selective to 2 or more analyte. But for organic precipitate, they are fairly selective, and by controlling the factors such as pH and concentrations, we enhance the selectivity of these precipitants. Okay, example for inorganics: silver nitrate, barium chloride. Okay, so silver nitrate used to precipitate highlight ions such as chloride, and barium chloride usually used to precipitate sulfate ions. So what is the advantage of organic precipitants? It forms chelate compound with cation, which is very insoluble in water, and then it has large molecular weight. And then third is precipitates obtained are usually bulky and coarse, thus easy to handle. Okay, this one is the common inorganic precipitate that you should remember. You should remember because this is very important. Okay, so this is the list of precipitants and analyte. Okay, and then precipitate form and precipitate weight. So what is the difference between precipitate form and precipitate weight? Precipitate form when you react precipitants with the analyte, so it forms this kind of compound. Okay, and then you need to dry, or sometimes it need to form a precipitate weight. Okay, such as here for analyte aluminium, you use ammonium hydroxide, you form a aluminium hydroxide precipitate. But its form is not stable, so please remember your precipitate should be stable. So you have four variable good precipitate. So the first the third that list is must be stable. So to make the stable precipitate, you need to dry and ignite here to become aluminium hydroxide. But for let's say here for silver, Ag, you react with hydrochloric acid and form precipitate silver chloride, which is we just dry it, no need to ignite it because this form of compound is already stable. So last after you dry it, you just wait the precipitate weight is in form of silver chloride. Okay, this is another some example you can read and please remember it, and also this one. Okay, so please remember everything in the table, from the species analyzed, precipitate form, what's form awaying, and interference species, because this species may interfere because, as I mentioned before, our precipitate sometimes are not very selective. Okay, this is an example of organic precipitate. You can read by yourself. This organic precipitates never asked any question before, so just read by yourself for your further information and knowledge. Okay, here also you can read by yourself, and this is the mechanism of precipitation. So before this, RS value, you should have smaller RS value, so you have more particle growth, so you will form a large crystal particles. So what is actually nucleation? What is the actually particle growth? So this mechanism of precipitate, I will going to explain details in our next video. So if you have any problem regarding in this video, so please ask your lecturer through WhatsApp, email, or any platform that can you use to reach your lecture. Okay, I hope you understand in this second video. So we'll meet again in our third video after this. Thank you.